This is question 1 from the second CSAT sample paper. And in this question we're simply asked to sketch the function f of x equals the minimum of t squared for t strictly less than x. So if you want to have a go at this question yourself, pause the video now. Okay, so first of all, what does this mean? This means we're looking at all the values t squared takes when t is strictly less than x, so we want to take the smallest one. As I'll explain in a second, there's a couple of ways you could interpret this, and I'm not sure which one they're looking for. But this is very easy to answer quickly, so it's worth just giving both answers and then discussing the difference. So first of all, how do we think about this? It's easiest to draw the curve y equals x squared, and then suppose we pick a point x, so it's easier to start with this one because then there's no trouble with interpretation. I look at all t less than x, so everything to the left, and I want the smallest value the function takes on that range. So for something to the right of 0, the smallest value is going to be 0. So for everything over here, the value is going to be 0. The place where I'm not sure exactly what they mean is if we go to the left, say, to something negative. So suppose this is x equals minus 1, and the value here is y equals 1 on the curve y equals x squared. So if we look at all t strictly less than minus 1, they take all the values strictly bigger than 1. So I'm not sure if they intend the minimum to then be 1, because that's at the end of that range, or if they intend the minimum not to exist because there's no minimum to the set of values this takes. In that this takes every value bigger than 1, so that means 1.1, 1.01, 1.001, etc. So there's no smallest element in that set. So normally in maths, when we use minimum, we do mean the second version I just said, so it means the smallest value in a set, and if there is no smallest value, then this just doesn't exist. But that isn't something we normally discuss at A-level, for instance, so it could be they intended this to mean, in the case I was talking about 1, because it's like at the end of the set of values this takes. So we'll sketch that in both cases. So first of all, what happens if it does mean the minimum in the mathematical sense? So if, suppose for instance I take the interval 0 to infinity, not including 0 because it says open brackets, then the minimum doesn't exist because there's no smallest value. Well then at 0, so for anything to the right of 0 we're fine because the value is 0. At 0 I've put an open circle because that point can't be included, because at 0, if t is strictly less than 0, t squared can take any value greater than 0, so any value in this range, but it can't actually take the value 0. So therefore, according to this interpretation, the minimum doesn't exist. And likewise, it doesn't exist to the left of 0. So this would be the graph. It would just be 0 to the right, an open circle here to show it's not included, nothing over here. If they mean the second one, what does that look like? This cycled, in mathematical terms, you're not meant to know this, but it's called the infimum. So for instance, if this interval 0 to infinity doesn't have the smallest value, but it does have every value greater than 0, then we say the infimum is 0. So perhaps that's what they mean by min in this case. Or in technical terms, the infimum is the greatest lower bounds. It's the largest number that's less than everything in this set. If that's what they meant, then what happens? Well, to the right, everything happens as before. At 0, now the answer is 0. And to the left, suppose I look at minus 1, then the infimum there is 1. If I look at minus 2, everything to the left takes values greater than or equal to 4, so the infimum there is 4. So basically the value at x, where x is negative, is just x squared, because everything to the left of that takes a bigger value. It takes every value greater than x squared. So to the left it looks just like the x squared curve. But as long as you can describe what interpretation you're giving, it's fine, I think, just to give one of these interpretations.